So in the last class, you have learned about the states of matter or what is matter, the properties of matter. Now today we shall learn about the states of matter. What do you mean by states of matter? Matter is going to appear in different forms. The different forms of matter are nothing but the states of matter. You are familiar with the different states of matter. The different states of matter are that you have to learn solids, liquids and gases. When I say solid, then you are going to see the pictures. So this is a pyramid and it is a solid, and here we have got the paper weight, it is a solid, and the bottle, it is a solid, and here we are using this to blow the balloons. It is what it is, solid, and the duster is a solid, the table is a solid, and the next one, water, it is a liquid, and we have got this colored substance, it is a liquid. Then the next one, another liquid, it is a liquid. Then what is there inside this? Nothing but air is inside this one. When we are going to close the lid, inside that air will be occupied. We can't see air. So in that way, we have got the three states of matter: solid, liquid and gases. Now today, one by one, we shall learn the properties of solids, liquids and gases. So here, first one, that is the mass. What is mass? When we consider any matter, the matter has got mass. The mass is measured in terms of the weight. So here, whether it is a solid, whether it is a liquid, whether it is a gas, all have got definite mass. So here, how it is? The weight of me or weight of the table. What is the weight of the liquid? You are going to buy the milk, you are going to buy the oil, that will be measured one weight, 1 liter, or it will be measured 1 kg. So mass we are going to measure. In the same way, you are going to get LPG cylinder. On that cylinder, it will be marked whether it is 14.4 kgs, 13.5 kgs, like that. In that way, all the substances, whether matter, it has got the mass. And mass we are going to express in terms of weight of the substance. So here, when we consider the mass of the solid, they have got definite mass. In the same way, here it is also has got definite mass. Gases, they have also have got the definite mass. Then the next one is about the shape and the size and the volume. When we consider the solids, solids have got definite shape. So this is the shape of the paper weight. It is, what is the shape? It is having a cuboid shape. And when we consider the pyramid, in case of the pyramid, all the sides, they are made up of triangle, and the bottom, it is made up of a square. In that way, when we consider the chalk, it has got the shape of the cylinder. And when we consider the duster is having the cuboid shape, and when we are going to consider this, it has got the cylindrical shape along with the different one. So when I am going to say name of any solid, then you will have the picture of the shape of it. But when I am going to say 1 liter of water, what you are going to see? Whether it is kept where, whether it is packed like the milk, or whether you are going to keep that in a bottle, or you are going to put that in a beaker, or the next one, if you are going to make that to flow in a pipe, what about that? Its shape goes on changing, and the size also goes on changing. Then what about the next one? It is called as the volume. In case of the solids, what about the volume? The volume is definite. We can can measure what is the length, what is the breadth and what is the height. And also we can calculate the volume of this pyramid by using the formula. And the next one, when we are going to consider the liquids, in case of the liquid, they are going to take the volume of the substance in which we are going to put it. So here, when we are going to see the water, it has only this much of water it is there, it is going to occupy the place like this. But I am going to pour that here. Then whatever the volume it is going to occupy, it will be different. And when we are going to consider the same substance, if I am going to put it, where I am going to put that? Inside the object which has got the different shape, then what it will do? It will take the shape or volume in that is inside this. In that way, what is volume? Volume is the place or the space occupied by the substance, or in case of the solid, it is the shape that we are going to consider as the volume, or it is the place occupied by the substance, that is called as a volume. So here, in case of the solids, its shape, size, volume, everything is definite, or it has got. But in case of the liquid, when we are going to consider the shape, size and volume, it will contain what it is going to take? The shape, size. So I am going to write that in short form, shape, size and volume of the container. The same thing we are going to consider in case of the gas. Gas is also going to take the shape, size and volume of the container, the thing in which we are going to put it, that it is going to occupy. Then the next one, filling in the container. When we are going to consider the solids, when I am going to put the solid inside a box, that is, I am going to put this piece of chalk inside the box completely to fill that, but some of the place it will be left. It will not occupy the whole place inside that container. But when I am going to consider a liquid, when I am going to put the liquid inside this, what happens to the liquid that I am going to put? It is going to occupy the place which is inside the container completely. No place will be left inside this one. In the same way, when we are going to blow the air inside the balloon, so what we have to know? When we blow the air inside the balloon, what do we do? What do we see? We see that the air is going to occupy the place inside the balloon. That is what we are going to study about, what it is filling the container. It is going to, when we consider the solid, they do not fill the container completely. But in case of the liquid, they are going to fill the container. So fill the container, and in the same way, when we are going to consider the gases, they are also going to fill the container. That means the substance in which we are going to put them, it is totally going to occupy the place. Then the next thing that we are going to consider is arrangement of the molecules, arrangement of the particles in case of solid, liquid and the gas. So here, when we are going to consider the arrangement, what do we see? In case of the solid, if this is a solid, how the particles will be arranged are molecules. We are going to see that the molecules will be arranged very closely packed. So there will be very less distance between each of the particle or each of the molecule. In that way, they will be tightly packed in case of the solids. So here, when we are going to consider this arrangement, the distance between what we call intramolecular distance is less in case of the solids because they are very near to each other. There will be force of attraction between the particles in case of the solids. When we are going to consider the liquids, in case of the liquids, what we are going to consider is the arrangement of particles. How they are going to arrange. In case of the liquids, there will be distance between the particles. So you can see how I am going to write. Here they are written tightly packed. There is no place between the particles. Here the place between the particles, and then number of particles here is more, but here the number of particles it is less. So here the distance between the particles is more compared to solids, and because of that the force of attraction between the particles is less when we are going to compare with solids. Then when we are going to consider the gases, in case of the gases, so what do we consider? Again, how the particles will be? The particles are very far away from each other. The distance between the particles is little more when we compare with the gases. And when we are going to consider the same place, the number of particles that will be less in case of the gases. In that way, we can consider what it is arrangement of molecules in case of the solids. They are tightly packed. And the next one, force of attraction is more. Now when we are going to consider the liquids, what we are going to consider? Distance is more between the particles. Because of that, force of attraction is less compared to solids. But in case of gases, what about the distance? They are very far away from each other. Particles are, what we are going to say, far away from each other. And what is the next thing? When we are going to consider the distance is more, force of attraction very less. Is very less in case of the what it is gases. Now the next property that we have to consider is flowing. Now if I have kept the solid here, is it able to move? No, it will not flow. Therefore, when we consider the solids do not flow. But when we are going to consider the liquid, in case of the liquid, when I am going to make this liquid, so what I am going to do? If I am going to pour the liquid, what will happen? It will start flowing. Therefore, liquids have got the property of they are going to flow. But what about the gases? In case of the gases, so here again that we can see by lighting this incense stick. So here when we are going to consider the gases, in case of the gases, you can see what happens to this fragrance. When we are going to consider these fumes, what they will do? As soon as it starts burning, see, you are going to see the fumes, and within a second we will not be able to see these fumes. What they will do? They are going to flow. That is what we are going to consider in case of the gases. So they are going to flow. Because of that, these liquid and gases, because of the property about the flowing, they are called as fluids. What are fluids? Fluids are the substances that have got the property of flowing. So, liquid and gases, they are called as fluids. Then the next one, it is called as the rigidity. So, what is rigidity? When we are going to consider these substances, this shape, it will be definite. It is not going to change. So here, when I consider a piece of chalk, only unless I am going to write it on the board, if you keep it on the table, it won't change its shape. It will be rigid. Then the next one, when we are going to consider the water, what happens to the water? It is going to change its shape according to the container in which I am going to put. In the same way, when we are going to consider the what it is, air. What about the air? When I am going to blow the balloon, it is going to, what it is going to do? It is going to occupy the place inside this one, and if the same air, if I am going to leave, what happens to the shape of this air that is inside the balloon? It is going to lose that within a second when it is going to come out. In that way, what we consider is, in case of the solids, solids have got rigid. But what about the liquid and gases? They are not rigid. So they are not rigid. Then the next one is the compressibility. What is compressibility? When we are going to apply the force or pressure on the object, whether it is going to change the shape or not, that property is called as compressibility. So here, when I apply the force on this one, is it going to change the shape? No, it is not going to change the shape, or it is not going to change the volume. The volume will be one and the same. In the same way, when I am going to apply the force or pressure on the liquid, then it is not going to change the volume. The volume will be definite. But what happens to air when we are going to apply the force? So here we are applying the pressure. What about the air? The air is getting inside. Now what I do is I apply the force. Because I am going to apply the force or pressure on this, what about the air that is inside it? It goes on changing its shape or volume. Because of that one, what we are going to say, solids and liquids do not have the property of compressibility. When pressure is applied, they do not change. But in case of the gases, when we are going to apply the pressure, they are going to change their shape or volume. So here, because of that one, what we can do is, we are going to fill the air in a balloon. We are going to fill the air in the ball. You are going to fill the air in your cycle tires. Like that, you are going to do. Then what will happen? The air goes on getting inside that one. Now the next thing that we are going to consider is about, so what we have to do, in case of compressibility, they do not compressible. In the same way, liquids also, they are do not compressible. But in case of the gases, they are compressible. We can apply pressure and fill more and more inside the box. Then the next one, that property we are, so compressibility means do not what it is going to do? In case of solids, they do not compressible. In case of the liquid, they are also do not compressible. And in case of the gases, they are compressible. The next one that we are going to consider is the property of diffusion. So what is diffusion? These molecules, what are they in case of solids, in case of liquids, in case of gases, whether they are going to mix with each other easily by the movement only. That property is called as the diffusion. In case of the solids, once the solid is made, these particles, they will not flow. Because of that, what they do not have? They do not have free movement. The force of attraction between the particles is more. Because of that, they cannot diffuse. That means mix with each other. When we keep one substance with another substance, what happens to these two? They feel or they look separately. They do not mix with each other. Now, when we are going to consider water, I am going to put a drop of ink color into this. Now, what did you see? You are going to see the color. And what happens to the color? It is not like a drop. It will mix with the water. The reason for that one is, so see the drop of color, then what will happen to the color? The color is going to mix with the water inside it. This free movement of the particles, when we are going to put that in one liquid, that is called as the diffusion. In the same way, when we are going to burn this incense stick, what you are seeing the fumes. What about the fumes? The fumes are going to mix with the air immediately. See, because of this reason, when you go home in the evening, if your mother is preparing the pulao, at the door only you are going to get the smell of it and you will be very happy. See, mother has prepared pulao, so I can have it. The smell, what you are going to get. The reason for that one is because of this property of gases getting mixed with another gas very easily. Because of that one, we can get the smell of the substances. So here, when we consider the property of diffusion, what we are going to say? They do not diffuse, but they are going to undergo diffusion or diffuse. Here also, they are going to diffuse. In case of this one, the diffusion is very fast. In case of the gases, the diffusion is very fast. In that way, we are going to consider the difference in the properties of solids, liquids and the gases. Now we have got the chart showing it, arrangement of the particles in case of the solids. In case of the particles, they are very tightly packed. Because of that, they have got definite shape, size and volume. And the next one, because of that one, all the particles, they will be having the vibration. But when they are going to do the vibration, they do not leave their places. And when we are going to consider the solids, in that we consider the crystalline solid, amorphous solid. Crystalline solids, they have got definite shape. Along with that, the particles are arranged in crystal lattice. But in case of the amorphous, the molecules are not arranged in a particular order. The example for crystals, they are iron, diamond, ice, salt. In case of the amorphous, it is rubber, wax, glass, cotton candy. They were not having the definite arrangement of the particles. Then the next one that we are going to consider is the liquids. In case of the liquids, they are going to take the shape of the container. And the next one, the particles are not closely packed. And the next one, that they are going to flow easily. And in case of the gases, they have no definite shape, definite volume, definite size. So here, when we consider the particles are very far away from each other, and it is going to, gases are going to move much farther, particles are much farther. And but what is one thing in case of the gases is, they have got more energy. The particles have got more energy than the particles of liquids and gases, because these particles are free to move. Because they are going to move very freely and faster, they have got more energy in them. In that way, we are going to consider the part, what it is, the different states of matter, solids, liquids and gases. So with this, I am going to conclude today's class. In the next class, we can study about how this solid, liquid and gases can be changed. Whether we can change the state of matter, solid to liquid, liquid to gas, or gases to solid, gases to liquid. So that we shall study in the next class. Thank you, children.